7.2, properties of graphs of quadratic functions. So in our last lesson, we talked about certain properties like the vertex, what the domain and range are, our x and y intercepts, and how to find those things. So just remember from that lesson that the vertex of a quadratic function is either the max or the min point of the parabola. So either the highest value if it opens down, or the lowest value that it's at if it opens up. To find the vertex from an equation, we use the symmetry of the parabola to help us. So we know that it's going to be the middle of our graph, so whatever our x value is there, and we can use the equation to identify that. So example 1 is we want to find the vertex of the following quadratic functions and state if the vertex is a maximum or a minimum. So based on what our a value tells us from last lesson as well, our a value tells us if it's opening up or down, whether it's positive or negative. So looking at a, I know that a is opening up. If it's opening up, I have a min value because it's going to go on forever opening up. So I have a minimum value in a, and I want to identify what that point's going to be. So the axis of symmetry, if we want to write ourselves a note here first, our axis of symmetry will be halfway between two identical y values. So if we plot some points here on our first one, say -2, -1, 0, 1, 2. So plotting -2 squared is 4. Minus 2 times -2 is +4. +4 will give us a 12. -1 squared is 1. Minus 2 times -1 is +2. +4 is 7. 0 squared is 0. Minus 2 times 0 is 0. +4 is 4. 1 squared is 1. Minus 2 times 1 is -2. +4 is 3. And 2 squared is 4. Minus 2 times 4 is -8. Sorry, minus 2 times 2 is 4. +4. 2 of those 4s will cancel, and we're left with 4. So the axis of symmetry will be halfway between two identical y values. So where I see two of the same y values is right here. And our axis of symmetry is always your x value. So we have the same y value, so it needs to be in the middle of our x values. So the vertex is in the middle, so what number is in between 0 and 1? Or sorry, 0 and 2, I just said it, is 1. So in between these two, x would equal 1. So I identify a vertex, now I need to figure out, well, what's my y value then when my x is 1? So I plug that into our equation. 1 squared minus 2 times 1 plus 4. 1 minus 2 plus 4 equals 3. So my vertex of this graph is at 1 and 3. And state if the vertex is a max or a min. Well, we said earlier our a value is positive, so it's opening up. So I know that this is also a minimum value. B, making a table of values. This graph is opening down. I have a negative a value, so I'll have a max value here. My vertex will be a max. -2 squared is 4, but then a negative is applied onto that in our equation. So I have -4. Plus 3 times -2 is -6 minus 4. So -14. When my x is -1, -1 squared is 1, but apply the negative to it is a -1. Plus 3 times -1 is -3. Minus 4 gives us -8. Plugging our zeros in, zeros cancel anything that has an x attached to it, so just our -4. Otherwise we'd have 0 plus 0 minus 4. Plugging our 1 in, 1 squared with a negative is -1, plus 3 minus 4, -2. And 2 squared is 4, but negative 4 plus 3 times 2 is 6, minus 4, negative 8 plus 6 is negative 2. So again, recognizing or identifying our identical y values are these last two terms here. They both have a negative 2y. So my x value of my vertex is the middle of my x values at those points. So to always find the middle, you can think back to our stats unit. X will be, you add them up and divide by 2. What's the middle of those if you're ever not sure? 3 divided by 2 is 1.5. So what is my vertex when my x is that? Y equals negative 1.5 squared plus 3 times 1.5 minus 4. Gives us a negative 1.75. So my vertex, my x value is 1.5, my y is negative 1.75, and as we discussed at the start, it's opening down, so this will be my max value. Last one for C here. Again, if you don't see a C value, it's really just 0. Negative 2, negative 1, 0, 1, 2. So negative 2 squared is 4 times 2 is 8. Plus 6 times negative 2 is negative 12. Gives us a negative 4. Negative 1 squared is 1 times 2 is 2. Plus 6 times negative 1 is negative 6, which gives us a negative 4. We don't really have to keep going because we've already identified our two y values, but we can finish the table. 0 plus 0 is 0. Or all of those will cancel to be zeros. 1 squared is 1 times 2 is 2. Plus 6 times 1 will give us 8. And 2 squared is 4 times 2 is 8. Plus 6 times 2 is 12, which is 20. Okay, so again, identifying our identical y values. My x value for my vertex will be in between negative 2 and negative 1. So negative 3 divided by 2 now. So I should have the same thing as before, just a negative 1.5. However, we can't just assume that our y value is just going to be a positive 1.75 like our last question. It's going to change. So plugging that in to our equation, 2 times negative 1.5 squared plus 6 times negative 1.5 gives us a negative 4.5. So our vertex is at negative 1.5 and negative 4.5. It's opening up. My a value is positive, so this will be a minimum value. Example 2, a water arc at a splash pad is defined by the quadratic function f of x, which is interchangeable for y. So f of x or y equals negative 0.15x squared plus 3x. Graph the function and state its domain and range. So it's easiest right now for us to use a table of values to identify these points. We know there'll be an x or a y-intercept of 0 because our c value is not there, so it's really a 0. So I know I'll have this point on my graph. We don't know any other points yet. So using a table of values. I'm going to go up by 5, so 0. I know I don't have any negatives. 0, 5, 10, 15, 20, let's say. If I plug a 0 into this function, my y value will be 0. 5 squared times negative 0.15 is 11.25. 10 squared is 100 times negative 0.15. So negative 15. Positive 15, sorry. $15 squared times negative 0.15 plus 3 times 15 is 11.25 again. And 20 squared times negative 0.15 plus 3 times 20 is 60, which will give us 0 altogether. All right, so here's our points. We have identical y values at 11.25. So what would be in the middle of 5 and 15? Well, you can already kind of see that point. It's right here. But you're ever not sure. Our x value, 15 plus 5 divided by 2 is 20 divided by 2, which is 10. And normally we'd take that 10, plug it into our equation, but we already have that value in our table of values, so we know that our vertex is 10 and 15. So 10 and 15 on our graph. So my x's are going up by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is here. 2, 4, 6, 8, 10, 12, 14. 15 will be here. The other points that we know are 5 and 11.25 and 15 and 11.25 if we want to plot those two. And 20 and 0. Those are all our points that were on our table. We can see it's opening down. Oh, I'll try that again. We want to make sure we go through our points. So we know it's opening down because my a value is negative. It's a very wide graph because our a value is also in between 0 and 1. And it's moved to the right of our graph with when our b value is 3. Y-intercept is 0 because our c value would be 0. The last part this question wants us to do is to state its domain and range. So domain, again, is all the x values that this question will be contained. So we're talking about an arc. We won't have a negative measurement for how far the arc that the splash pad goes. So our domain is between our lowest to our highest x value, so 0 and 20. So we write that as x is greater than or equal to 0, but less than or equal to 20. And our range y is greater than or equal to 0, but less than or equal to our highest value for y was 15 in our vertex. So this whole graph is everything left and right between 0 and 20 for our x's, and everything between 0 and 15 for our y values.